Are we alone in the universe? It's the question that humans have been asking for millennia. We may not have a solid answer yet, but luckily NASA's been working on it. They've sent landers to Mars and are planning to send a probe to Jupiter's moon Europa in the 2020s. But how will NASA or other space agencies know an alien if they see one? That's where planetary protection comes in. It's the idea of limiting the amount of Earth organisms we bring to other planets. Even before NASA's Apollo missions, the agency realized that Earth contamination could muck up the search for extraterrestrial life. Life exists everywhere on our planet, so that means any vehicles we send into space will probably have Earth life on them too. That will make it hard for a spacecraft to know if it's found an actual alien or just a stowaway microbe from Earth. Planetary protection became international law back in 1967 with the signing of the Outer Space Treaty. The treaty set up a lot of key rules for space law, like prohibiting nukes in orbit and forbidding countries from claiming other planets. It also stated that countries should conduct exploration of other bodies so as to avoid their harmful contamination. For NASA, that means adhering to guidelines set up by the Committee on Space Research, or COSPAR. The committee lays out rules for what you need to do if you want to send spacecraft to another object in the solar system, and the rules change depending on where you want to go. To make things easy, NASA classifies missions based on where they're going in the solar system, kind of like Star Trek. Landers going to the moon or an asteroid are considered Class 2 missions. That means the destinations have a really low chance of having life. So if you want to go to those places, the rules are pretty simple. Document what you brought with you and where you left your spacecraft. The rules get extra strict if you're doing a Class 4 mission. Those involve landing on the 3 places that have the highest potential for life: Jupiter's moon Europa, Saturn's moon Enceladus, and our neighbor Mars. It's all because of liquid water, an essential ingredient for life on Earth. Both Europa and Enceladus are thought to have subsurface oceans, and many studies point to water on Mars. So if you want to land on any of those worlds, you'll need to go through extensive sterilization to make sure your spacecraft is as microbe-free as possible. For Mars, there are different rules depending on where you want to go on the planet too. That's because NASA's defined certain spots on Mars as special. These are places where temperature and water conditions are just right so that Earth life might grow. Like Mars's recurring slope lineae, areas of flowing salt water that pop up during the planet's warmest months. To visit those places, spacecraft have to go through an extra sterilization step: getting baked. It's the same procedure the Viking spacecraft had to go through in the 1970s. When NASA sent those first landers to Mars, the spacecraft were heated in an oven for about 3 days. This reduced the amount of organisms clinging to the spacecraft. Those Viking missions revealed Mars to be a hostile environment, though, so the rules for visiting were relaxed for a while. But after finding these special regions on Mars, NASA made it a requirement to bake any spacecraft that may want to visit one of the planet's hotspots. Still, Earth microbes are resilient. Just before NASA launched the Curiosity rover, 377 strains of bacteria were found on the spacecraft, and 11% of those strains were shown to survive UV radiation, extreme cold, and other crazy environments. That means many of the microbes likely survived Curiosity's trip. So planetary protection may not be able to eliminate all the Earth organisms we send to other planets, but it can at least ensure as little contamination of our galactic neighborhood as possible. Hey, it's Wilderness Week on The Verge. We're celebrating the 100th anniversary of the National Park Service, so check out all our cool content related to the great outdoors on theverge.com or check out our videos linked here.